Hiya, in this video, I'm just going to go through two more examples of polynomial division using the reverse box method. So far, I've only looked at a quadratic divided by a linear. And in this course, we won't go much further past dividing by a linear. And by a linear, I simply mean a polynomial of degree 1. This is a cubic. It's a polynomial of degree 3. Now, the reverse box method requires you to create the box to start with, but how many boxes do we need? Well, look at the leading term or the degree of the polynomial that you're dividing into. So that's this one here. The degree of the polynomial is 3, so that'll tell you how many boxes to go to the right. So I'm going to have 3 boxes this way. And because I'm dividing by a linear function, a polynomial of degree 1, I just need 2 boxes that way for the x and the plus 3 on the side here. So that's all you need to worry about. And we won't go past a polynomial of degree 1 as our division, although of course you can do if you needed to. So it's exactly the same method. It's just a matter of having the right number of boxes. And of course, if you put the wrong number of boxes and you run out of boxes, put more at the end. So, if you can't remember that, it's the same as the degree of the polynomial, doesn't matter. So same deal though. We look at the leading term. There we go. And it'll go into this box here. And then we say x times what equals x cubed, and the answer is x squared. Therefore, I can work out this box here. 3 times x squared is 3x squared. Lovely, lovely, lovely. I'm now looking across the diagonals here. These two diagonals have to add up to this term here. So, strangely enough, I have to add nothing to 3x squared to get 3x squared. And so I'll put it in so that we've got it there. But that's what it looks like. And then x times what will give me 0x squared, and the answer is 0x. Bit weird, isn't it? 3 times 0 is equal to, is equal to 0 here. Now looking along this diagonal for this value here, 0 plus what equals 2x? The answer is 2x. X times what will give me 2x? The answer is plus 2. And then 3 times 2 is equal to 6, which is the same as the last term here. So it goes into it evenly, but with this middle term here, which just happens to be nothing, and that's fine, which means that we can say that x cubed plus 3x squared plus 2x plus 6 divided by x plus 3 is exactly equal to x squared plus 0x, not putting it in, plus 2. Or to put it another way, x cubed plus 3x squared plus 2x plus 6 is equal to x squared plus 2 multiplied by x plus 3. So there you go. A bit weird, but nevertheless, it's okay to have 0 terms popping up. We can just ignore them at the end, but the process still works. Here's another weird example. Looking at slide 14 here, we've got x cubed plus 1 divided by x plus 1. Remember, that's what that fraction means. So even though there are only 2 terms here, it's the degree of the polynomial that determines the boxes. So I pop the boxes up like so, and I put the thing I'm dividing by on the left-hand side like so, x plus 1. As usual, the leading term gets put into this box here. So that's x cubed, and away we go through the process. X times what equals x cubed? The answer is x squared. Fill in the missing box. 1 times x squared is x squared, like so. Now here's the trick. X squared plus what will leave me with nothing, no x squared term. Well, the thing is, I'd have to subtract x squared, right? That'll give me 0. So x squared minus x squared is 0. and there's 0 x squareds here. Okay, let's fill in the boxes. X times what will give me negative x squared? The answer is negative x. 1 times negative x is negative x, like so. Same deal again. There is no x term here, which means that I have to sorry, my iPad just did something weird then. I have to add x to get rid of the minus x there. I have to return this back to 0. And so I follow my process again. I've got x times what equals x. X times 1 will give me x. And then I'm going to multiply 1 by 1 here. I get 1, which is the same as the constant term here. So therefore, it again goes in exactly evenly. There is no remainder left whatsoever. If there was, we would have to write it down. But we can conclude that x cubed plus 1 divided by x plus 1 is exactly equal to x squared minus x plus 1. Another way of writing that is that x cubed plus 1 is equal to x plus 1 multiplied by x squared minus x plus 1. Okay, with no remainder, so it's exactly equal to that, which is maybe counterintuitive, but it is true that this is the way it is. So there you go. So you can do it with cubics. I could do it with a power of 4 as well, with just extra boxes. So it is very much an expandable process. Okay, I'll leave this video here.